The topic that we are going to discuss today, it is very important, okay, and it is generally known as Kirchhoff law, okay. So you understand it properly, and if you require suppose more explanation part, again we will do it, okay. Now to understand the Kirchhoff law, some basic terminology we must know, and those terminologies are like junction point, loop, network, okay. So here I am drawing one diagram so that you can understand the meaning properly. Let's say there are two cells, and these two cells, they are connected with, and they are having the internal registers R1 and R2. Their EMF are E1 and E2 respectively. And this is third external resistance R3. So A, B, C, D, E, F. Okay. Now, first of all, what is junction? Okay. Junction. See, in this electric circuit, there are 2 points, and these 2 points are F and C. You can find there are three branches. Okay, this is 1, 2, 3. So the point in the network where more than two branches they meet, okay, where more than two branches, okay, more than two branches meet. That is what junction point. Now next thing comes, that is the loop. Now what is loop? Any closed path along or inside a circuit, okay, any closed path in an electric circuit, that is known as loop. I hope everyone is clear regarding the two definition of this junction and the loop. Yes or no? Okay. So I hope everyone is clear regarding the junction and the loop. Tell me.
Yes, sir.
Okay. Now the first Kirchhoff's first law, it is known as junction law. Okay. Junction law. And in short, in some books, it is written as KCL. Okay. Kirchhoff Current
Sir,
Law. Yes, beta.
sir, can you again explain the loop part?
Loop. See, here in this circuit, if I talk about A, F, C, B, A, it is a closed path. Yes or no? Canal?
हाँ हाँ सर.
So this closed path is what? Loop only. Clear?
सर तो नीचे वाली FEDCE
Yes, F, E, D, C, F is
DF
another loop. Okay. Then you can
तो
consider
डायरेक्शन कैसे देंगे?
direction, so you can take any direction. Okay. A, E, D, C, B, A. Okay. Direction doesn't matter because current is not a vector quantity. Okay.
Okay.
Now over here, we will talk about the junction law first of all. Now what is the junction law? Okay. The junction law simply says algebraic sum of electric current at any junction point is 0. Again, I am repeating, algebraic sum of electric current at any junction point is 0. That is Kirchhoff current law or junction law. It is also known as first law, Kirchhoff's first law. And this can be modified. How come? Algebraic sum of incoming currents, that is equal to algebraic sum of outgoing currents at any junction point. So sum of incoming currents and sum of outgoing currents, that is same. Okay, or in other words you can say algebraic sum of electric current at any junction point is 0. Now let me tell you how come. Suppose if I talk about this first cell. So from the first cell, let's say I1 current is coming out. Okay. So at junction F, I1 current is entering. Now if I talk about the second cell E2, let's say I2 current is coming out of this. Now this I2 current is moving towards the junction point F. Okay. Now over here, the incoming currents are I1 and I2. So outgoing current in the branch FC, this one will be I1 plus I2. Now you can clearly observe for point F. Okay, for point F, incoming currents are I1 plus I2. Incoming currents are I1 plus I2 and outgoing current is I1 plus I2. Okay, the sum of incoming and sum of outgoing current at any junction point is constant. I hope everyone is clear regarding this point. Tell me.
Yes, sir.
Okay. Now if I talk about point C, again see in this branch, I1 plus I2 current is coming. So out of this I1 plus I2, the I1 current branch will move, I1 current will move in the branch CB, then B to A. Same way, I2 amount of current will move from C to D, then D to E. Okay. So the current is flowing here in the upper branch I1 and lower branch I2. Again over here for point C. For point C, again I can write here I1 plus I2. Algebraic sum of incoming currents equal to algebraic sum of outgoing currents I1 plus I2. Okay, I hope everyone is clear regarding these 2 points. Junction law. Any query?
So what's the full form of KCL?
KCL Kirchhoff Current Law.
Okay, sir.
Now, one of the most important thing I forgot to mention here, this Kirchhoff Current Law or Junction Law or the first law, it is based on law of conservation of charge. Okay, it is based on law of conservation of charge. Okay, so this was the first law. Now we will talk about the second law. The second law is known as loop law. Okay, loop law. Now this loop law, it is known as Kirchhoff voltage law, KVL. Kirchhoff voltage law. Now what is this Kirchhoff voltage law? According to this Kirchhoff voltage law, along a closed loop, it means if we move along a closed loop, algebraic sum of potential difference across the ends of each of the conductor in a closed path is 0 only. I hope everyone is clear regarding this. Tell me. Yes.
Yes.
Yes, beta. Okay, now to understand this, we need some sign convention. Okay, now what is the sign convention? If I see this branch F to C, okay, F to C, if I talk about current always flow from higher potential to lower potential. Okay, current flows from higher potential to lower potential. So if I talk about the potential drop for the V3, okay, potential drop of V3, it is going to be negative because we are moving from higher to lower potential. If we move from lower to higher potential, suppose, then we will take potential as positive. I hope it is clear to everyone. Tell me. I'm not getting any response. Students, if you are clear, just raise your hands quickly. कितने लोगों को समझ में आ
कैन
गया
यू
किरचॉफ? यस बेटा. कैनिल?
डायरेक्शन एक बार सिखा सकते हो?
Okay, direction I will take one example here, one complete example to explain it. Okay? Okay, everyone, just note down this so that I can explain you that Kirchhoff loop law. Okay? So now students understand this properly, right? So I am making a little bit bigger one. Right. Okay, here we come up with the first part. First of all, the current in the first branch, it is coming out here from the cell E1. So same amount of current you must enter inside it. I2 current, let's say, is coming from the E2 cell. So same amount of current I2 must enter it according to law of conservation of charge. Okay. So over here at junction B, the incoming currents are I1 and I2. So outgoing current
I1
here
plus I2.
will be I1 plus I2. Now at junction point E, out of I1 plus I2, I1 current is moving up and I2 current is flowing in this branch ED. Okay. Now to apply loop law, first of all, we have to select a loop. This is very, very important part. Okay. To apply loop law, we have to select a loop. So I am selecting one loop first of all, and mostly try to select the loop in the direction of current. Again, I am saying select loop in the direction of current. Okay. So I am selecting first one A, B, E, F, A. Okay. This is A, B, E, F, A. Now remember that whenever we move in the direction of current, in the loop, if we move in the direction of current, we will take voltage as negative. And if we move opposite to the direction of current in the circuit, we will take voltage as positive. Then, if I talk about a cell, in a specific cell, if we are moving from positive to negative, then EMF of the cell we will write minus negative. And if we are moving from negative terminal to positive terminal in a cell, then we are going to write plus E. Yes, I hope everyone is clear regarding the sign convention. Tell me.
Yes.
Kenel? Yes, Kenel. You are asking about the sign convention. Are you clear with that?
Sir, a little.
Okay. Now I am coming to one example here with the loop. I am writing the equation and you all must focus here. First of all, from A to B. Okay, from A to B. There is no resistance, so we will not write anything. No potential drop. A to B, no potential drop. Now from B to E. If I talk about B to E, the resistance is R3, current is I1 plus I2. And we are moving in the direction of current, plus to minus, in the direction of current. So in the direction of current, we will take minus sign first of all. Then we will write I1 plus I2 and resistance is R3. Is the step clear to everyone? Tell me.
सर
हाँ बेटा बोलिए.
तो मतलब पॉजिटिव टर्मिनल के पहले तो माइनस लगाएंगे.
Of course, we are moving from higher to lower potential, means value is decreasing now.
Yes.
Okay.
Understood.
Now from E to D, E to D you can see, sorry, E to F, we have taken E to F. So E to F, there is no resistance again. So nothing we will write. Now F to A, when we are moving from F to A, first of all, I will talk about this much part only, R1. So again we are moving in the direction of current, what I will write, minus I1 R1. Okay, because we are moving from higher potential to lower potential. So minus I1 R1. Now in case of cell, we are moving from negative terminal to positive terminal. So from negative to positive, I told you we will consider even positive. Yes, I hope everyone is clear regarding this, and total sum equals to 0. Tell me everyone if you are clear with this or not.
Yes, sir.
Yes, sir.
So simply I can say E1 equals to I1 R1 plus I1 plus I2 into R3. Now I will call the name of the student and I am going to ask from you people only that whether you understood it or not properly just by telling me the correct response. Okay, first of all, Prakriti, beta, Prakriti, are you there?
Yes, sir.
Okay, Prakriti. So here I am taking a loop, okay, and my preference is B, E, D, C, B. Okay. Now in this loop, you tell me for B to E, what shall I write according to Kirchhoff's second law? B to E, what shall I write? Yes, Prakriti. Prakriti, I cannot hear you. Are you saying something or? देखो इससे पता चलता है क्लास में आप कितना अटेंशन पे कर रहे हैं बेटा प्रकृति
Yes, sir.
okay Sumit you tell me what shall I write for the loop B E D C B Sumit
Yes, sir.
yes tell me for the loop B E D C B first I am taking B to E so what shall I write according to Kirchhoff's second law loop law
Uh,
for B to E part very good Sumit
yes, sir.
इसका मतलब आप भी क्लास में कोई भी अटेंशन नहीं दे रहे हैं परम परम आर यू देयर परम
Yes, sir.
yes now you tell me for this loop B E D C B what shall I write for B to E first of all साइलेंस छा गया मतलब ये भी परम
Yes, sir.
are you responding or not
Sir, I don't know the answer.
आंसर तब दे पाएंगे ना बेटा when you will focus here in the class the very important topic is discussed and you people are keeping silence even though if you are not understanding you are not daring to ask the question Nirav
Yes, sir.
Nirav you tell me what shall I take from B to E first of all according to Kirchhoff's second law
Sir, minus
minus
I1 I2
I1
plus I2
plus I2.
R3.
Very good. Now from E to D there is no resistance, so we will not write anything. From D to C, okay, first resistance is there. So from D to this part, what shall I write?
Sir, minus
Very
I2
good.
R2
Minus I2.
R2
Okay, then
then E2 plus E2
plus or minus.
uh, sir,
यहाँ देखो यहाँ साइन बना रखा है देखिए
plus
when
plus plus
plus
plus
E2
E2
equals to 0 because now C to B there is nothing. So I can simply write E2 equals to I1 plus I2 into R3 plus I2 R2. Okay. चलिए अब एक लूप हम किसी और से भी पूछ लेते हैं बिकॉज आई डोंट थिंक कि स्टूडेंट्स आर पेइंग अटेंशन हियर. सो next we talk to Akshat. Akshat, are you there?
Yes, sir.
So Akshat, I am taking the loop A, B, C, D, E, F, A, right? For A to B, what shall I write? Tell me.
Mm.
There is no
There
resistance.
is no resistance.
So 0. Okay.
0. Yes, sir.
B to C, there is no resistance. Correct?
Yes, sir.
Now from C to D, remember that current is moving in this direction, D to C, but we are moving from C to D.
D.
So first of all, cell is there, plus to minus. What shall I write?
Mm.
Plus to minus.
Sir,
Here it is in front of you.
minus E.
Minus E2 beta. Okay.
Yes, sir, minus E.
Okay, now here we are moving opposite to the direction of current, right? So
Yes,
this
sir.
is plus and this is minus. So we are moving opposite to the direction of current. What shall I write now?
Minus E2
minus नहीं
equal
see देखो in the direction of current so we take minus. But when we are moving opposite to the direction of current, then what we have taken?
positive.
Plus. And see from minus to plus we are moving. Minus to plus means value will increase or decrease? Yes,
Increase.
Akshat. Increase. So what we will take? Positive value. Clear?
Yes, sir.
Now again D to E and E to F. There is no resistance, not to worry. Now again come from F to A. So again for F to A, first of all we are moving from plus to minus on the R1. So what shall I write? Plus to minus.
Minus
Yes.
I1 R1.
Very good. Now from this minus to plus.
Minus to plus. Plus
Minus
E.
to plus. What plus? E1 or E2 or E?
Even.
Very good. So finally we reach to A and this is equal to 0. Okay.
Okay.
Now how many of you are clear with this Kirchhoff's second law? Just raise your
Sir, I have
hands.
a
I have to
question.
check. Who has a question?
Sir, Dhruv.
Yes, Dhruv.
Sir, when we are moving towards the current in
Hmm.
then what will be the sign of P?
See, when we are moving in the direction of current means what? From higher potential to lower potential. Yes or no?
Yes.
So higher to lower if we will go, so what we will write? Minus.
Sir,
Let me finish this first bit. First part is clear to you, Dhruv?
Yes.
And whenever we are moving from opposite to the direction of the current, like if I take this example, here it is from minus to plus. Okay, we are moving from minus to plus. So what we will take? Plus I2 R2 in case of resistance. Dhruv, these two things are clear to you?
Yes.
Now, if I talk about the cell, in the cell, observe here. If I say that I am going from minus to plus means increasing. So value is increasing, so I have written here plus E. While if I go from plus to minus, you can see this case, plus to minus. So plus to minus means value is decreasing, so I will take minus E. I hope now you are clear. Tell me.
Yes, sir.
Okay. Yes, who was there who was asking something?